There are few other functions that I want to talk about. For example, concat, upper, lower, etc. Now we have already seen what coalesce does. Coalesce basically replaces a particular column value. If that value is null, then it will replace with the value that you provide. Then you have concat. Concat is essentially concatenating two different columns or one column with another string, so on and so forth. So that's what concat is used for, and it is very much useful when you execute select statement to generate a report, because maybe you want to concatenate multiple columns to show a value which makes business sense. So then you can use this particular function, which is concat. Then you have length. Typically, length is used to find out the length of a particular column. And then we have lower, which changes uppercase string to lowercase. And upper changes the opposite, lowercase string to uppercase. Then we have replace. We can replace a particular string with something else. And then we have substring. Substring is basically used to find out the subset of an entire string. And one of the very important functions is cast, which can be used to change the data type. So let's do some hands-on. Again, I'll use order tables because there are a lot of different data types in order tables. Okay, so what will I do? I'll drop the product code column. This is actually not necessary. All right, it is done. Now let me see the rows. So these are the various rows. Now what I want to do is, let me concatenate the price along with the discount in the order invoice. So I want to showcase the discount, and I want to showcase the discounted price. I want to concatenate them. First of all, let me show you how it works. So let's say select concat my name, and then is data engineering, and it will show you, it has to be a function, my bad. So this is how the output would be. My name is DE, and we do not use pipe, we use comma separated values, and all these values would be concatenated. Now let me show you. If I, let's say, concatenate price and then discount from orders. Now I have to mention from because these are columns belonging to order table, so I'll have to use from here. So limit 10. Now obviously it does not make any sense, right? So what I want to show is, I want to show this is the price, and along with that there would be a string. Let's say total price is this, which would be the price, and then it will also show you discount, which is this, and I can find that out. So the total price is 67.93, and then the discount is 12.39, and then I can mention the discounted price also. So what would be the discounted price? So I can concatenate, and here I'll have to mention some function, right? So that would be the mathematical function, which is price minus price into discount. I hope that is the column name. Yep, price into discount divided by 100. So this is what it is showing. Discounted price is, of course I'll have to put some space here. Okay, so the total price is 675.93, the discount is 12.39, and the discounted price is 592 point something something. So again, this does not look pretty nice, so we can change it, and that's where cast would be helpful. But as of now, this is how concatenation works. So you can concatenate multiple values, and you want to send this output or print this output in your invoice. So you can obviously use an application program which will do the printing or generate the output, but you can use SQL statement concatenate function to output something like this. And of course you can mention other values like order ID also. So here I can select the order ID, and this is, again, as you can see, the column name is concat. I can use an alias here, and it is showing this is the invoice details for each order. This is the invoice details, total price, discounted price, sorry, discount, and the discounted price. Now, because I have come across this, let me show you cast. Now, it does not make sense to showcase this particular value like this. So let me first run it in a simpler way. All right, so what I want to do is that I want to, let's say, cast order date to timestamp, because this is date, but I want timestamp. So how do you do that? This is a function. So I'll have to pass multiple arguments, and I'll mention order date and then followed by as timestamp. And as you can see, it has been converted to timestamp because you see 000 here. Why 00? Because I do not have any time here, so that's why it has taken 00. Similarly, I can cast price as text also. Let's say price as text. So then price would become a text string. Again, this is only in the output, not in the table. So the casting is being done on the output result, not on the actual data. Remember that. The actual data remains as is. So whenever you cast, the database engine will get the record from the tables, and then it will apply the cast function on the output. The actual data will never change. And it is true for all the functions. All right, now let's do a little bit complicated casting. So this is what we were selecting, right? So what I'll do is I'll cast this particular value as decimal 10 comma 2. Then it would look nice, right? So I have removed concatenation, and this is the price. So remember, I'll have to put price in bracket because the first argument is a single column, or a single, not column actually, value of a column. So that's why I'll have to put a bracket here, and then I can mention cast, start a bracket. This is the bracket for cast, and I'll end the back bracket for cast, and then as decimal 10 comma 2. So now, as you can see, the output is pretty nice. And this is what we want to implement in the invoice also, because definitely we do not want to show the output like the way we were showing. So this is how the output is now. So as you can see, the discounted price is 592.18, only two decimals. So all of them are having two decimal values. So this is how you can do cast, and you can basically change the data type of the columns. Now again, as I said, the functions, whatever functions I have talked about, all those functions are applied on the output rows. The actual table data type never changes. The database engine, in this case Postgres, will retrieve the records from storage, and that becomes the result set, meaning there are so many output rows. So that is a set, and the functions would be applied on the result set. Now, as I have talked about select multiple times, I'll show you two very important statements. One of them is called CTAS, or select create table as, and the other one is insert into. For both the things, we need select statement. The CTAS is called as create table as, and after that, we actually mention a select clause. It is something like this: create table, let's say order details as select, followed by the entire select statement. The same thing is true for insert into also. Let's say I want to insert some value in a new table, and I can select those values from an existing table also. And this select statement can be any select statement with multiple functions. So what will I do now is I'll create a table wherein I want to store the invoice details. So the total price, the discount, the discounted price, the order date, delivery date, and the order ID, and the customer ID also. Basically what I'm saying is this particular output would be stored in a table. All right, so I'll create a table. So create table, order ID would be integer, just like the previous table. This is not CTAS, I'm showing you insert into. Delivery date data type would also be date. Total price would be decimal, and data type of discounted price is also decimal. Okay, so the table has been created. If I type /d, I should be able to see order details. Now I want to insert values here. And the thing is that I do not have a file. I want to insert the value in this particular table by selecting value from orders table and doing some operation on top of it. So what will I do? I'll mention insert into and order details, and then I'll start the select statement. Remember, so in the select statement, I should have the exact same columns as that of order details. Let's say the number of columns are smaller or lesser than the actual table. So in that case, we'll have to mention the column names here. So maybe I want to insert only order ID and order date. So I'll have to mention order ID and order date, and then select order ID and order date from that other table. But in this case, I do not want to do that. I want to to store some process data. So insert into order details. So what am I doing here is, as you can see, this is a normal select statement that we had run earlier. But this time I want to insert the output of the select statement into this particular table. Okay, seems like I forgot a bracket, and 100 records have been inserted. Now if I do a select start from order details, I should be able to see 100 records, but now with different columns. So we have order ID, order date, delivery date, total price, and discounted price. These are the columns. And these are columns that I have inserted from a different table using the select statement. I did some processing in the select statement, and then I inserted the values, and this is what the processing was. This is the select statement. So this is called insert into select. Then we have create table as also, that is called CTAS. So how do you do that? You can create table as, let's say order. I'll create the same tables again and mention order details 2 as this one. Now what would happen is, in the previous one I had to define the table, but in this case I'll not define the table. Create table order details as, now it is done. So if I do a select star from order details 2 and let's say limit 10, what is happening? This is the output, but the columns are not actually correct, right? So here the column name is some gibberish. So in this case, what I have done, I did not define the table beforehand. I just mentioned the table in create table, then table name, and then as the select order ID. Now let's take a look at the data type of this table, which has been created automatically. So as you can see, the first one is integer, which is similar to the original table or the source table. The second one is date. The third one is date. Price is numeric 82, which is similar to the data type that is there in the source table. What is the source table? It is orders, because I'm selecting the columns for orders. But for the last one, it has selected decimal some 00. So what will I do is, if you want to create a table in a better way, so let me mention it as order 3, and you'll have to cast it, and you know what casting is. So now if I execute this, and let's see the data type. So as you can see, the data types are perfectly fine because I had mentioned that in the select statement. And if I run a select star, the output would be as per our expectation. So this is the price and this is the discounted price, and then delivery date, etc., etc. This is how we can use CTAS and insert into select, and these are very, very powerful tools, because let's say you want to create a different table based on a report requirement, and maybe the report requirement is new, and all the tables that you have do not cater to that particular requirement. So maybe you create a new table using some select statement like this. And then in future, when you load these table, or when you load the new table, you can use some processing framework like Spark or Glue, etc.